Before starting the presentation, we want to thank the EXARC and the conference organizers for accepting this paper on our ongoing experimental project, which aims to replicate an ancient Greek pottery kiln and the whole operative sequence of pottery production. This project, which is part of my PhD, poses the following research questions. First, to understand how local available raw materials such as clay, temper, and fuel influence pottery production and successful firing of ancient Greek wares. Second, to understand how many pots of a variety of shapes could be produced in a medium-small size kiln for each firing. Third, we also aim to monitor the firing conditions during each stage of the process. And finally, we want to understand how different types of local firewood influence the firing process. We investigated evidence of pottery workshops from all the Greek world, from archaic to Hellenistic period, but we decided to focus on a rural workshop from the territory of Metaponto in southern Italy, Sant'Angelo Vecchio, that belongs to the late 4th, early 3rd century BC. It is an interesting context with a wide variety of pottery and ceramics products for everyday life in a rural settlement. We also compare the archaeological data with ethnoarchaeological research on potters using pre-industrial technologies from Mediterranean area, especially from Spain. The experimental research, which is funded by the HRC Northwest Consortium Doctoral Training Partnership Fieldwork Fund for current PhD students, is taking place in the Whalley Range area of Manchester, UK. The plan of the kiln has been designed according to the most common kiln typology in the Greek world. It has a circular combustion chamber of 1 meter of diameter with a central pillar to support the perforated floor. The stocking channel is 60 centimeters wide and long, according to the average measures of kilns in the archaeological evidence. For the combustion chamber, we adapted a firing pit already used for Neolithic and Bronze Age firings, and it is 50 centimeters deep. The dome will have a maximum inner height of 1 meter, all depending on the total volume of pots to fire. The permanent structure of the combustion chamber and stocking channel is made of traditional Victorian bricks, held together with soil and sand, and then lined with adobe mix in the inner and outer sides to improve insulation. They are arranged with an alternation of stretches and headers to provide more stability. The rows of bricks are narrowing from the base to the upper part in order to give the shape of the dome. The central pillar will be made with raw bricks according to the archaeological record. The dome will have a base of traditional bricks, the middle part will be made of raw handmade bricks, and the top will be a mix of unrefined clay with grog or coarse sand. The upper part of the kiln will be of course temporary. Finally, on both sides, at the base of the dome, there are going to be 2 removable bricks facing each other to allow a Greek replica iron hook to take samples to check firing, following traditional potter's practice. There are also going to be 3 thermocouples just above the perforated platform, as well as 2 in the middle of the dome to monitor temperature in all relevant sections of the kiln. Here is a series of pictures of the making of the permanent structure. We arrange the bricks around the pit to shape the permanent structure. Then the vortex arch of the stocking channel has been provisionally made with a removable frame of bricks and clay bags. For the final kiln arrangement, we are going to deepen the pit to allow the arch vortex to be 12 centimeters under ground surface level. A wooden arch will be cut off for that purpose. As I have already said, the middle part of the dome will be made out of raw handmade bricks. They are made of natural clay from the Whalley Range area tempered with sand. The mixture then has been packed into a wooden frame of 9 by 20 centimeters. After drying under the sun for a couple of days, they have been measured and weighted, and we found out that the shrinkage rate is 10% after drying. In order to make the perforated floor, which is going to be a key element of the kiln, a fine sieved local clay, tempered with 30% of coarse sand reaching quartz, has been used. We designed a 1 meter platform 10 centimeters thick. Considering a 10% shrinkage rate after drying, we have added 10 centimeters to the diameter and 2 centimeters to the thickness. We agreed to build the platform by making 6 portions averaging 45 degrees each, except for one as twice as wide, which will be placed at the entrance of the combustion chamber. This has been decided for 3 main reasons. 1. During firing, we will limit the risk of breakage to individual sections rather than to the whole platform. 2. There was no space to model the entire platform. 3. It would have been quite heavy to lift and carry, therefore transporting the single sections would be much easier. The vent holes have been evenly distributed throughout the surface of each portion. Here are the stages of the making of the perforated platform. Wet loaves of sand tempered clay were stuck together starting from the center towards the external part. A stick has been placed at the center and a rotating cord was used to measure the radius of the portions. Once the sections were smoothed, the vent holes were made using a wide and strong branch of around 8 cm diameter. When the portions were ready, they were left in the cellar to dry out. It has been necessary to spend more than 1 week kneading the clay and the sand and to make each portion. The rural workshop of Sant'Angelo Vecchio in the territory of Metaponto, excavated and published by the University of Texas at Austin, offered a great variety of shapes for everyday life uses. Drawings and pictures from the 2016 volume have been used as a reference for shaping and wheel throwing the pots. The shapes selected for the wheel throwing are the black gloss ware, banded ware, plain and coarse wares, and cooking wares. To prepare the clay for the pottery, first of all we broke the raw local clay with a hammer or spade, and then we soaked it into buckets for weeks or months. Later the clay was squeezed by hand and sieved twice to remove inclusions and obtain a fine clay body. During the following weeks, clay was kept covered to skim the excess water. Then it was dried under the sun or over plaster slabs to absorb humidity until it was consistent enough to be modeled. Lastly, clay was carefully kneaded to remove air bubbles. The percentage of temper added to our local clay depends on the intended use of each pot. For example, for cooking wares, a greater amount of finely sieved sand has been added to let the clay body become more refractory during cooking. For each kind of pot, the original clay body, coarse or fine, and the dimensions have been replicated as much as possible, adding a 10% in all dimensions to compensate shrinkage. For throwing the pots, we used a kick wheel that was the most common amongst Spanish traditional potters until the introduction of electric motors in 1960s. In order to replicate the black gloss of black gloss wares, we mashed intense red clay into a fine powder. Following our references, we mixed 874 grams of clay, 2.040 ml water and 4.7 ml sodium silicate. We left the mixture to rest for 72 hours, then we siphoned the upper and finer solution, then we boiled it to evaporate and produce a dense consistency. Finally, we applied it to the surface of the pots with a brush or by dipping the pot into the slip. We aim to turn it into black gloss after creating a reducing atmosphere at the final stages of firing. Here are some examples of thrown pots: Ionic B cups, bowls, basins, scifoi, cooking pots, and loom weights. For the pre-firing session, first of all, we will do a pit fire to dry the combustion chamber and the stoking channel. In the second session, we will fit the central pillar and the perforated floor to prefire it for 7 to 8 hours to let the water in the clay to evaporate slowly. This operation will also allow us to check how flames flow through the holes. A last prefiring session will be done to check the draft and also to dry the adobe walls. Basing on ethnographic evidence from Iberian Peninsula and transferring our skills from Neolithic pit firing and modern gas kiln practice, this is our plan for the firing process. From ambient temperature to 100 centigrades, we warm up and dry the kiln dome. A small fire will be set at the entrance of the stoking channel to gently heat the kiln. If the heat is too intense, trapped steam may make the pots explode. We must always accept that some pots are going to be lost at this stage. From 100 to 400 centigrades, we will increase the fuel intake and push the red ashes in the combustion chamber using an ancient Greek T-shaped iron rod replica like this one. Between 400 to 550 degrees, the water contained in the chemical composition of clay will be released. After about 550 centigrades, clay is transformed into ceramic. After 550 centigrades, we can increase temperature in order to transform soft fired clay into hard biscuit. When thermocouples indicate temperature above 850 centigrades, we will start taking painted samples to check slip sintering and vitrification. From gas test firing, we expect that our sigillata slip will vitrify at temperatures around 900 centigrades. When slip is vitrified, we will introduce green plants and close the stoking channel and chimney to produce smoke and reducing atmosphere. The pots will turn into a grey or black color. When the temperature is below 800 degrees, the stoking channel and the chimney will be opened again to produce reoxidation as a result. Unpainted pot sections will become red again, but those areas covered with sigillata should remain black, as sinter sigillata should retain the carbon molecules. Lastly, we will leave the kiln to cool down slowly by sealing the chimney and the stoking channel with bricks and clay. This stage must last at least 24 hours and always be monitored by thermocouples before opening the kiln at temperatures below 100 centigrades. During the stages of the experiment, we faced some challenges and issues. Due to the humid climate of Manchester and damp cellar conditions, it took up to 6 months to dry the perforated platform's portions. Indeed, in the Mediterranean climate, the drying time would have been much shorter. Another challenge was replicating the pots out of partial archaeological drawings, so that the overall shapes and dimensions were figured out on the basis of general type shapes and our own experience and interpretation. Third and most annoying issue was the COVID-19 outbreak and subsequent travel restrictions in spring and summer 2020, so that we had to delay the firing process to 2021. Despite the problem, we can draw some conclusions what we have done so far. The clay and temper collected in the area of the experiment's place had above 90% successful firing rate in more than 10 gas kiln tests and pit firings. The timing of the stages of the chain of operatoire of pottery production and kiln building largely depends on seasonal and geographic climate. Making the perforated floor, clay processing and wheel throwing were the most time-consuming stages of the operative sequence. Lastly, we can conclude that the potter's experience, as well as learning from trial and error, matters to face challenging, finding solutions to problems and choosing the right raw materials amongst the available ones in order to get a successful production. As a further development of this experiment, besides its contribution to my PhD project, it can be a source of educational activities for a British audience to understand the meaning and technological context of the Roman kilns found throughout England since the era development of Greek technology. Figurine, pot making, and decoration can add genuine excitement to experimental archaeology activities. Furthermore, the wide variety of late Hellenistic household pots can be used for teaching everyday life and cooking practices in ancient Greece and Magna Graecia. Thank you for your attention, and we hope to present the results of the firing process in a further EXARC conference.